In this video, we're going to look at how LAN-Caster does stepping forward in time, or moves one frame to the next. And we've talked a little bit about this in the video on the code overview for the server, but we're going to go much deeper into that. And I specifically skipped talking about one class that's in that server. So I talked about the server, I talked about server map, but server map actually inherits from a class called stepMap. So if we look at that, and I haven't talked about this in detail a lot, but when the server, and I'm actually going to look at the server code here. So this is the server.py in the engine. When it loads, see if I can get this correct. Okay, so when it loads its maps here in the code, it actually loads a server map. So server map is this class here, and server map inherits from stepMap, and stepMap inherits from map, and map inherits from the base type in Python called a dictionary. So not worrying too much about all of that detail, you don't have to absorb all that, but it's just important to know that between your basic map and your server map, you have a step map. Now on the client, you don't have this. The client map, it inherits directly from the base map. So only the server has step map, and this is pretty key. So within stepMap, there's a couple key functions, and I'm just going to jump past a whole bunch of initialization and things like that because they are important, but they're not ones you have to understand the details of. What you really need to understand is the stepMap method and what it does. And the stepMap method, it moves the map forward one step in time. So we see this used in the server code. So if we go to server.py and we scroll down to the main loop, we see that we call step server in the main loop. And if we go find step server, we see that what it does is it finds, through all of this code, it finds all the maps that have players on them and calls stepMap. And that's the function we're going to talk about. So in the server, all of this code here finds, again, the maps that have players on them. And for each of those maps, it calls stepMap. Sorry, yeah, stepMap, which is the key function here. So if I get back in here now and find stepMap. Oops, sorry, I'm still in the init. There we go. So I am in the engine folder with the code, and I'm in the stepmap.py. So what this function's going to do, it's going to take a map and move it one step forward in time. And this applies directly to how you write game mechanics. You get a certain set of function calls, and this is going to go through and run those function calls in a particular order, and it's going to run them in that order every time. And I've already talked in the previous videos about how you can subclass server map from the engine into your game and then subclass it again into your map. It can get very confusing. So I'm not going to concentrate on this code. What I'm going to do is just go a little bit higher up and just look at the comment. So if you're in stepMap and you want to understand really the details, you can just give this a read. And what it says is that to move a map forward in time, it's just going to run all the game mechanics that make up the map. And each of those game mechanics can have these functions. So this applies directly to how you write a game mechanic. So again, for each map, for each step, your game mechanic is going to have its functions called. And whatever the name of you can just fill in the name of your game mechanic here. And LAN-Caster, the game engine, is going to worry about finding all of these game mechanics and all of their what they do and things like that. And I'll go into the details of a bunch of examples of game mechanics. This is just to show you that how this works, generally speaking. So these functions, and I'll just summarize them here on the screen because it's a little less detail than what's in the actual comments for the step map. But when you write a game mechanic, there's kind of one init function you write, and then there's a bunch of, actually this is interesting, this has lost the game mechanic. Let me actually go back and use the actual, I just lost something with HTML, that's all. So if I go back to tutorials here, yeah, there we go. I'm just going to make this bigger, much bigger. Okay, not that big. There we go. So this is the video we're talking about here. So each of these function calls, and I'll just make it a little smaller again, just to try and get it all on one screen. Okay, there we go. For your game mechanic, each of these function calls are part of a well-defined system to move the game forward one step. Now, your game mechanic can have an init that's only going to be called once when the map's loaded. It's just kind of like a class init almost. It's whatever you have to do to set up your game mechanic. And then every single step, your game mechanic has the options to run some code at the very beginning of the step, to run some code at the very end of the step, and then two options during the step. And there's two things that happen here. The first one is a game mechanic can have a trigger, and that'll be called anytime a sprite collides with a trigger. Now, again, I'll go into details on this later when we actually look at some game mechanics, but a sprite, when we talk about its anchor point, normally what we're going to see is an anchor point of a sprite colliding with a rectangle that's sitting on the trigger layer. So a sprite sitting on the sprite layer, or an object on the sprite layer, usually a tile object with its anchor point, being inside the rectangle of an object on the trigger layer. And that's going to cause this to be called. That'll make a lot more sense when we see some examples. And the other one here is the movement. If a sprite's in motion and you have movement as part of your mechanic, then your mechanic will be called. It's much more likely that you're going to implement mechanics that use trigger, and less likely that you'll implement mechanics that do movement. The trigger is by far the biggest one, or the start map or the end map are definitely the most common ones to use. All right, so I'm not, again, skimming over the details at this point, but I want to show you how do you figure out this mess. I just explained a huge mess of subclassing and functions and things that call functions. How do we know what the heck's happening? So what there is, when you start the server, you can add the verbose flag. And I'm going to show you the difference between these two things. So if I go to my run demo right now and I look at my server start script, there's no verbose flag. So I'm just going to run the demo right now. All right, so I'm going to go look at the server. So this was all the output that the server produced when we started it up. So very, very little. It told me which players joined the game, my IP address, and tells me the game mode is game on now. If you haven't looked closely at this logging, by the way, it's very, very useful to use the log function. You can look in the code for LAN-Caster how to do logging. It's much more useful to do this than to do print, because this will actually tell you the function, exactly what time it came out, all those sort of things. Highly recommend using this over print. Okay, let's turn on verbose. So we're going to go back here. So what I'm going to do on the server is I'm going to add verbose. And this basically makes the server output more information. I'm going to go back and run this again. And we're going to look at the server. All right, so now what we have, and actually we have to scroll up because there's so much. We have all of this information that has come out. And I'm going to concentrate really on the map information. So if I look, and I look at the, there we go. And we see right here, we see the load modules map end, it's importing demo maps and server map. So I've subclassed this to the particular map. So I see that in the demo game, in the maps folder, in the end map, I am using the server map from there. So that's what I'm importing. It tells me what actual map file it's loading. It tells me that it found several different objects and several different layers. So verbose is giving me a lot of information, but it's the next one that I really care about here. And the next one, actually what I'm going to do is I'm going to stop the server so that it stops telling me how busy it is. Let me just tell it to stop, and then I can scroll back up. So I just press Control-C there to get it to stop. So then I see the map end method. So the name of the map is end. So the map end methods. And what I get is all of the methods that have been defined for my server map class. So all of the ones from the end server map, all the ones from the demo game server map, all the ones from the engine server map, all of the ones from the step map, and all the methods from the map itself, and even from the base dictionary type in Python. All of these things are here. So these are all the method calls that you can make on this object, this map object. And again, I'm concentrating on the step here. So two things. We see the init list. So things like the bomb area and the chicken, these are things specific to the either the map, the server map in the end or in the game. But you'll also see ones like map door. That one's from the engine. So we see different inits. So those are all going to get run when the map is loaded. And then each step across the bottom here, you're going to see exactly what's going to happen. So when the server calls step, it's very simple. It's going to call each of these start map functions or methods in this order. Then it's going to call all of these triggers in this order, but only if a sprite is colliding with something on the trigger layer. Okay, so only if there's a collision will it get called. Then for any sprite that's in motion, it's going to call the step function. There could be more than one, but here there's one. It's called move linear. And then it's going to call all of these when the step ends. And then the step's over. And then when it comes back around, we do that again. And we just repeating it. And that's how the game runs. So anybody on the end map, if a player's on the end map, this runs every step. And then it runs again every step. That's how it is. That's all there is to a step. Those are the methods that will be called in the order they're called. Now, there are some subtleties here. For instance, the trigger, if we have 4 different players inside the same holdable trigger, then yeah, holdable would be called 4 times, once for each sprite inside the trigger. And if a sprite is inside 4 triggers, then the sprite will be called for all 4 triggers. So all of the collisions happen there. But besides that, it's just one-to-one calling. This will become a little more clear when we look at that, but that's just to show you if you've written a bunch of functions and you don't know if they're loading properly or if they're in place, you can add the dash verbose, just to remind you what that looks like. You're just going to add dash verbose to the start server, and then you can actually find your map. So let's say your map was an map, and you can see, did my function get loaded? Is my function in the right place? Did it find my methods that need to be called? I'm using function and method interchangeably, probably not correctly there, but you understand what I'm saying, I hope. Okay, and then any other methods that you add as well will be listed there, and you'll see them. Also, if you want to add a new method, you can look here to make sure it's not already there. I mean, it's unlikely for you to have collisions with the names, but you can look through all of these lists to see if a method you want to add already exists. So you should definitely do that. Okay, so that's the basics of stepping. In some of the other videos, I'm actually going to look at how the game mechanics work. And we're actually going to see that those game mechanics contain stepMap start methods and trigger methods and step move methods and these things. And you'll see how you start to formulate those to actually move it forward.